Okay, so today I'm gonna be solving problem of the day, Leetcode 1402, that is reducing dishes. So the problem states a chef has collected data on satisfaction level of his n dishes. Chef can cook only one dish in 1 unit of time. Light time coefficient of a dish is defined as the time taken to cook that dish, including previous dishes multiplied by its satisfaction level, that is time into satisfaction of I. Return the maximum sum of light time coefficient at the end that a chef can obtain after the dishes preparation. Dishes can be prepared in any order, and the chef can discard some dishes to get this maximum value. Okay, so let's look at the satisfaction array. Let's open MS Paint. Okay, let's use some pencil. Okay, now satisfaction array is given as -1, -8, 0, 5, and -9. So what this actually means is like we need to maximize what we need to maximize and discard some. We need to just get the maximum value, that is maximum sum of lifetime coefficient. So if initially if we do the sum, that would be -1 into 1 plus -8 into 2 plus 0 into 3 plus 5 into 4 plus -9 into 5. This case is -1, -17, -17 0, 23, and this 3 minus 45, that is -42. Okay, but this is absolutely not the maximum sum that we can get. This is pretty clear. Okay, because like if I don't include -8, then my sum would be -1 into 1. And now since I'm skipping this, so the second dish that would be cooked is 0. So 0 into 2, and then I the third dish which would be cooked is the one which costs 5. So 5 into 3. Now we can also not take this, so answer would be 15 minus 1, that is 14. Okay, let's look at another test case. This is 4, 3, 2. Okay, so 4, 3, and 2. Now, let's see. This is 1, 2, and 3. If I do the sum, that would be 4 into 1 plus 3 into 2 plus 2 into 3. This is 6 plus 6 plus 4. That is 16. Now, let me try to rearrange the array. Let's do something like 2, 3, 4. Now it would be 1 into 2 plus 2 into 3 plus 3 into 4. That means 12 plus 6, 18, and this gives us 20. And you can verify that this would be the maximum sum. Okay, so now what can we do? Like I think let's look at another test case and maybe then things might come clear to you. This is -1, -4, and -5. -1, -4, and -5. So the thing is, the satisfaction level must remain positive. In no combination can we obtain a positive sum out of three negative integers. So the answer would be 0. Now, okay, now let me give you some hints related to the problem. Okay, so let's look at the first test case again, which was -1, -8, 0, 5, and -9. Now, what can we do is, let's, since I'm multiplying the latter numbers with its index plus 1, uh, then what if I keep the minimum value at the end, like -9, -8, -1, 0, and 5. Okay, so what this means is, let's see. Now if I take the sum, let's see what this gives me. 9 into minus 9 into 1, minus into 2, minus 1 into 3, 0 into 4, and 5 into 5. That gives me 25 minus 16 minus 9 0. This gives me minus 3. And earlier what it was giving me, it was giving me minus 42. So I think it is pretty clear that we need to sort the array so that the least integer gets the least value and the highest integer gets the highest value, because if the highest elements are kept later, then they would multiply it with an index with the value at their position, that is index, and that would be greater, producing a maximum result. Okay, so now what has to be done is, after we have done this, now there can be uh, okay, so now for each and every time we are checking, uh, like we need to take minus 9, minus 8, minus 1, as we need to take some of the negative elements, otherwise uh, the dishes to be cooked would be less and you cannot get the maximum value of the positive integer actually. So what I would do is, this is now a DP based solution. I can either take that element or not take that element. If I take that element, then I would just multiply it with this index plus 1. If I keep taking all the elements, then I would multiply it with index plus 1, index plus 1, index plus 1, and get the sum. But if I don't take the element, I would maintain another variable which is count of not take. Okay, initially this would be 0. Now I can now there would be two recursive calls. One would be if I take the element and then I move forward, and if I don't take the element, then I move forward. If I take the element, then count of not taken would remain as it is. If I don't take the element, then they would be incremented by 1, and the contribution of each element would be its index in its position, index of the element in the array plus 1 because of 1 based indexing, and minus of count not taken. And just try to understand what this is saying. I would code it up if my handwriting is not very clear, and then it would become pretty much more clearer to you. So this is index plus 1 minus count of not taken. Like if I don't take minus 9, the first dish to be cooked would be minus 8. If I don't take minus 8 as well, the first dish to be cooked would be minus 1. So index is plus 1, count of not taken is initially 0, and plus 1 for minus 8, and then I would come for when I come to minus 8, I have not taken minus 9 as well. Then its contribution would be 1. Then if I don't take minus 8 as well, the starting index would be minus 1. Okay. I think this is the best that I can explain. So let's try to code it up. I've already solved this problem, but I am going to solve it again. I would first of all, let me use a top-down approach, that is recursion. So let's try to create a function int f. This function would take an index. It would take the array. Let's call it arr, and let's also take another variable which is count not taken. Okay, now the base condition is pretty simple. If index is greater than or equal to arr dot size, then let's just return 0. Okay, now I have to make two recursive calls. One is if I either take the element, and other is if I don't take the element. If I take the element, it will be int take is equals to arr of index multiplied with index plus 1, because there is 0 based indexing, and 0 actually means first element, so plus 1 minus count not taken, and then I would just do a recursive call index plus 1 and arr and count not taken. This would remain as it is because I have taken the element, so the count of the number of elements that I have not taken shall remain the same. Now there will be no take. This would be f of index plus 1, and I would ARR and count not taken plus 1, and just return maximum of take and no take. Let's just return f of 0 comma satisfaction and 0. 0 is count of not taken, which is initially 0. Let's try to run this. Right. Oh, uh, yeah, silly mistake. I forgot to sort the array. Dot end. Okay, a typing mistake. Another typing mistake. Satisfaction dot begin and comma satisfaction dot end, and let's see if now this runs. I hope I'm not making another fault. Okay, this runs. Now this solution is correct, but let's look at the constraints. N is less than equals to 500. Obviously, this solution will give me a time limit exceeded because for each index I'm making two recursive calls. So the total time complexity would be around 2 raised to the power 500, which is O of 2 raised to the power 500, which is a lot, and obviously this would give a TLE. Okay, let's try to erase everything off. Now I'm going to convert this into a DP solution. So in the concept of dynamic programming, what we're actually doing is like we are trying to remember the recursive calls of a few functions so that our time complexity gets drastically reduced. So first I taken, let's see the index. Now for each variable of index, now for each index and count not taken, I would remember these values and convert this into a memoization. Okay, so let's try to memoize it. I think memoization is the simplest part of writing a DP solution. All you need to do is declare a vec, vector and int dp and n plus 1 comma vector int n plus 1 minus 1. It's always nice to take in n plus 1 as the size of the array, because what if while you're moving the index it crosses n, then that would not be very great and might give errors. Although in this condition there is no chance that index would reach the nth index because of this base condition, but still I just like declaring it as n plus 1. And let's pass the dp in here, pass by reference, otherwise the values would not get updated and our time complexity shall remain the same. Now this would be dp of index and count not taken. Okay, and also let's see if dp of index and count not taken is not equals to minus 1. If this now does not equals to minus 1, that means we have already crossed the state. Now when you have already crossed the state, you just want to return dp of index and count not taken. Since we are always generating maximum, so I don't think there should be any error. Like the maximum, since we are storing the maximum only, there will not be any negative condition, because the maximum would be to not take everything if all things are negative. Okay, now let's pass in the dp in here as dpr in here as well. I have passed it by reference. I think this should run. Let's see. Okay, all test cases, sample test cases have passed. Let's try to submit the solution. Oh god. Okay, I'm getting a time limit exceeded. Let's try to submit this once again. Still, time limit exceeded. What am I doing wrong? Let's see. Okay, so in this condition, top-down approach would not work as well. So I need to convert this into a tabulation format. So tabulation is pretty simple again. Uh, so yeah, let's try to do it. I need to run two loops. Int I is equals to 0, I is less than, god, I don't. Okay, so let's try it. I think what the problem was, I was passing the vector array by not by reference, so it was creating a copy of the original array each time the function was getting called. So now if I would try to submit this, I think this should work fine, and the not give material. Yeah, it did not. Again, this is not the best approach for solving this problem. I have seen a linear time solution for this. You can try to see in the solutions part, or if you have any doubt, then let me know in the comments and I can write the better approach as well. Thank you for watching.